How's it going, everyone? Welcome, Elia Gonzalez. That's right. So, in today's video, I'm going to explain quickly how I made this particular project, the word game. So as a way to explore and extend and dive deep into the technical aspect, but again, very straightforward. So then we can look at the solution. So why am I doing this? Well, this is just as a way to articulate all of my ideas, explain that in the most succinct and accurate way possible, and by looking at the solutions from Josh Comeau, the software engineer that has previously worked at Khan Academy and then Gatsby, what are the standards that the industry is now using as a way to make their life much more easy to maintain? Okay, but the TLDR of this is in today's video is going to take a look at this quick overview of how I made that. It might not be the best, but at least it actually is a working solution, which is something that a lot of the time, if you're gonna work for any company, this is what they want. This is what the reason why you are getting paid for, right? And then it is up to you to find ways to optimize this. Now, so this game, all right, we start by looking at the package JSON first. What are the libraries and commands that we're gonna use here? Since this is not a code by my author, this is from Josh Comeau. Okay, so the dependency here is using ESLint, this library for help us to fix common JavaScript problems. The other is the ESLint configuration for React app. Again, the same, but in this case for React. New component is a script that it follows this barrel component way to do so in React application, aka it defines now an entry point of this component as an index.js, and inside of that folder you have your components, the constants, the specific utility function that you might need, the type definition for that components. There's also some movement against the barrel, okay, or to this particular way of organizing code, and that is because for small to mid app like 100 to 500 components, this is not a big deal. But when you're starting to have now 1,000 or more components, which is not fair, is not wild to have them, especially in large companies, what it's doing is all of this index file is now adding extra hit before even the code is compiled or executed, right? Because this is now a process of, it's a step on the linking process. So the TLDR is that for this case, we're gonna go with this component, this folder structure, and then we can now use without it. Parcel is like a webpack. It's this model bundler, so it helps us here with minimizing the code and then do a code splitting, aka putting our code ready to be delivered to clients. Pretty is just to provide code formattings. Process is specific to Node. I don't know why they're using that. I'm assuming they're using that is for the new component. All right. React in itself, the platform where we're going to paint all of these components, and RimRaf, which is a nice library for removing a recursive force weight, like but in node folders, in node projects. So some of the script here, so you have the pref dev, right, as a way to actually make everything, so set everything for distribution, for production. The dev server which is running is here now Parcel, which provide of this nice convenient stuff like hot motor reload, or aka this loop feedback loop. When anytime that you edit the codes, it will reflect those changes on the browser. The build command is also from Parcel to actually build our application for production. And the new components here, which is again is part of the script, it's also part of the dependency as it is. And browser list, which this is something that comes from React and React DOM, particularly with I think there is this something comes from Parcel, because this is a library that help us to target specific JavaScript files to evergreen browsers, or to define is the target browser in which we want our app be available. Good. Now, when we explore the folder structure here, as it is, okay, here we look at the components. The entry point, of course, is the index. As you can see, this actually is now defining as the React components normally, and also the app. Importing is the CSS style here, for example, like reset, which is to make all of the HTML elements to be in the same to be on the same page, right? To look like the same across different browsers, and the current particular style for this app. And then let's go to now select the elements, particularly the root elements, and it's in there where we're going to now mount our app component. So you can take a look at the index.html, where you have is a basic HTML here with some meta. So hey, this document is follow the UTF-8 character set. It's also have a particular icon. We want to now is the viewport to be able to scroll the title, the links of where our CSS class will be. And now look at this. So now this script is acting like an ES6 model, right? From the browser perspective, based on this. And we're going to import that as expected, right? So here is the div. And as we explore is the reset. Again, this is part of the custom CSS reset. I'm not gonna dive deep into this. This just is to make all of the elements behave to look like the same across different browsers. The style is to, well, starting to provide now the look and feel of our app. Some of the utility functions that we need to, like for example, range. And I hit the break here with range because this is helpful, especially when you need to create is layout in React, right? Some of the data that we want to load here, some static data, some game helpers as well. So for example, like check guess. Hey, this is a correct guess. I also have my own naive solution made in 30 minutes, right? If you want to take a look at that, please be my guest. But it's actually behaves somewhat similar to this, which this is pretty much more readable. This solution is just whatever it come up from my mind the first time I look at how to create is the game logic, and I made that in 30 minutes. So that's why it is a naive solution. Next is the consents, right? So for example, hey, what are the number of guests allowed here? You get this. And now what we care about on the application is the component, the folder structure. So here we have our app. Inside of our app, as you can see, you have is the index, which is I explained, is this barrel folder structure. So here in the app, we just only have is the wrapper from the game. The game in itself is what is going to load is the answer. This is just to make debugging easier. And then it's going to now pass down to the search input, which is what we started to build initially. Because this is now the final versions of our code, all right? Exactly. So this is the final version of our code. To make now, to explain now is the sequence of how I implement this is also by following the README as Josh Comeau actually made that. So creating this kind of stuff is not simple. It requires is to dive deep into the so it requires you to dive deep into the nature of the problem. All right, but in our case, I define first the guest input, all right, and how now I specify some constraint. So for example, like min and max input that is required, and also that this is the particular pattern that I want to do so. And the HTML validation when that pattern doesn't match, right, with title. And control that input via React by setting it in a state and do this data binding. So after that, okay, then I look at, okay, now that I have the input, so what are the output of this? That I want is to render all of these elements or track all of the guests. And that's exactly what we did here. That was pretty straightforward. It's not that hard to do so. What was a challenge was to think about is in terms of the layout. This requires CSS knowledge. There's a particularly course, again, taught by Josh Comeau, that he also mentioned, I went through the fundamental of CSS, what are the things that are still relevant in CSS, and the rendering logic, aka how now CSS actually work the way it does. What is this cascade style? What is the direction, the content direction, whether it's inline or block, and how, because now our audience that we are serving much more, that we are now serving content is wider, aka is cross-cultural, meaning that it's not for Western, but also it involves, for example, South African or Middle East or the Asia, right? So for example, like hand-based characters. Most of those applications are not designed for hands-based characters. It most likely follow is the left to right way of reading content. But for example, in the Middle East, the content now is shown by right to left. And how to understand in what are the tools available that CSS allow us to do so. And then is understanding that CSS is like a mini set of mini language that has its own particular layout, and each one of those layout will indicate how a box will behave, aka the way how now is the browser represent is different HTML documents or HTML tags into a visual representations as a box. And the anatomy of this is made of a content, the padding, the border, and the margin. We also look at the different properties and the shorthands and edge cases and also the outline. Um, eh, and then now explore is the different layouts modes that we have. So for example is the basic one, the normal layout, where inside of this you have is an anatomy. So this layer, this algorithm, when you put now by default, when you use any of these boxes, by default it follows this particularly layout algorithm that has is three boxes or three type of boxes. So you have the block, the inline, and inline block. We also look at how it behaves each one of them, and also is how the width and height is calculated, right? The TLDR is that by default, when you don't specify is the width or the height, the width is going to look up the tree to compute that, and the height down the tree. Okay, and also is what is margin collapse. So this is only exclusive for the normal or the flow layout. So right now I'm in that particular course, I just look at that. There are different type of layouts. So for example, position absolute, relative, the float, flexbox, grid, all right? But so far I have looked at what I mentioned. So, but in any case, this is important. This is the reason why it is important for us to understand now if you're going to be a front-end developer working with Angular or even with any other framework out there, it is important to understand the fundamentals, okay? So that's great because I look at how to create this. And if you remember that every element is a box from CSS, so what I did is just, well, let's going to define is a container that hold all of this, okay? And then I say, hey, container, I'm going to use now a flexbox, which is a particularly layout algorithm. Let's say, hey, all of it is children that I define here. I want to now is take all the horizontal space, aka flex column, flex direction column. And then it put now all of these span elements that I mentioned, and then horizontally, right? And then I say inside of this rectangle, sort of speaking, right? Inside of this, I want to put now more elements here, which is the character length or the word length. I want to put now 5 elements here. That the container of those 5 elements will behave also as a flexbox, but in this case each one of them is now a row, which is the behavior by default. So this is how you can actually create this. And also there is some particularly or some peculiarities here. For example, how do you put this round border here and here and here and here, right? So the TLDR is that we actually select those particular elements via the first or last n of type, and then apply the border rules here. Okay, so that was quite verbose of my side, and also it was very interesting when I went through that to actually be able to describe is the thinking process. But when I now apply this game logic here, which is actually show each independent color, all right? So if there is a gray color, it means that it is the word is not exist. So the letter doesn't exist in the word. If it's orange, the letter exists but is not in the right spot. and if it's green, it is in the exists and it is in the right spot. Good. So in order to do that, so as we render each one of them, okay, so we're saying is, hey React, I want you to now render is all of the guesses, right? And then complete the the other empty boxes as well. So in other words, the first time we actually is printing the first iteration like first, all right? And then below we're saying, hey, now let's go to render is 5 empty slots. When the user now hit enter here, it actually update with the second guess, which is about, right? And we're telling React, hey, let's go to render is this, so the guess collections, and then the empty collections, right? And so on and so forth. So this is the systematic way of doing that, the mechanics here. And also we add now, well, this is also why I spend a little bit of time to think about the game logic by my own. I didn't want to use the logic that they use that actually works, but it turns out that I end up using is their own logic just to match is the entire example. So this was pretty interesting because as we render each one of those letters, we can now add or return is a function which is part of the make guess. We are returning is now a collections where all of these particular letters will now have is the right color. That was very, very interesting. And again, because this is a fixed length collection, there's nothing wrong with that. That's actually work as expected. But if this collection actually, of course, is huge, you will need to find other ways to go and improve that. Again, premature optimizations can be the root of all evils. So after that, right, we add this winning and losing, which was pretty straightforward. To say it was not that pretty straightforward. In fact, I have to stop, hit the brake, because I do need to add this particularly banners and trigger only when it's needed. AKA, I need to keep track is if the user actually make a guess, and also to show how many attempts left, and add all of those state updates inside of the handler, right? So here is now the stretch goals. If you're looking for additional challenge, give these stretch goals a shot. Unlike the standard exercise, no solution video is available for these goals. Through the raw solution source code is available. See the solution page of the course platform. Also feel free to come up with your own sketch or stretch goal. If there is a thing you like to implement, go for it. So we have the visual keyword. So in the real world game, a keyword is shown below the guesses. Exactly. So the idea here is, in our case, well, and not only that, is that it's showing is this key, the keyword here, where we already use that particularly word. Okay, this is actually the real game as well. And there is some restart button. One of the word hooks is that you can only play one game per day. There is a new word of all users every day. As a result, there is no restart button. So you just have to wait until the next day. In our clone, we are picking a new word every day. We're pick a new word when the app first load. Update the game so it can be restarted. Add a restart game button to the banner show when the user win or lose. So again, to restart this might be to the straightforward solution is to reload the page. Reloading the page. Hint, it will require moving the answer into a state. You'll want to do random word selections instead of a callback functions, and the secondary way to initialize state describe is here, right? So, but in any case, now let's take a look at the solution. This is my own game here, right? The game that I make here. It is live, right? Hello, world. There, I don't know what the word is. A peanut, no peanut, no. Amber, no, it's not. Well, I don't know what the word is. I don't know. No, I don't know. It's okay. It is an O. Let me see if I can cheat here, so you cannot see what I'm doing. Let me see. What about O? This is an O. The TH about. What the French toast is that? Is using TH. Is using TH. Is using O. And it starts from an O. It'll be what, like. Okay, what the front? Holy moly! It'll be what, words? Oh crap! I got my last attempt. I don't know what it is. But we're using is H, O, M, and T, and H. O and T, M, H, and T, H. It'll be mouth. Mouth. Oh, is month. Well, anyway, I was close. I was damn close. Anyway, but you get the idea, right? And also, is the input is not being selectable. So there you got it. Good. So let's take a look at this, right? This exercise requires us to wire the text input and a form and check up the data binding and form submission. Lesson for a refresher.
So the starter code for this project, it's pretty sparse, right? There isn't really that much here. We have a header and a placeholder. And that can feel a little bit daunting, right? There is a whole lot to do before we have a functional Wordle clone, but Rome wasn't built in a day, and our Wordle clone will take place over several exercises. And in the first exercise, we're going to focus exclusively on building the guess input component, so the place where I can enter the guess, type it in, and submit it. And we'll deal with all the other stuff a little bit later. The README says to create a new component and to render it inside game, so that's exactly what we're going to do. I'm also going to copy this chunk of HTML, because that'll come in handy shortly. To create the new component, I'm going to type npm run new component, and then I'm going to name this component guess input. If you're wondering what all this stuff is, it was described in the project overview video that should have been just before this one. So if you haven't seen it, please do go back and watch it. It'll tell you exactly what I'm doing with this, as well as share a whole bunch of other stuff that'll be really important and will make for a much smoother experience throughout this project. Okay, so I run that code. It gives me a brand new component created over here, and I'm going to take that HTML that I copied and plop it right in. I do have to remember that this is HTML, not JSX, and so I have to make a few small tweaks. I have to change class to class name, and I have to change for to HTML4. When I do that, I'm going to come over to game. I'm going to import the new guess input component from its sibling folder, and I'm going to render that in the spot that this placeholder currently is. And when I do that, we are met with, dare I say, a rather polished and finished looking form input. It looks a lot better than it...
Oh, for real? Don't tell me that. Don't tell me that. Oh, that's interesting. Don't tell me that. Don't tell me that. Don't tell me that. I'll be right back. Alright, and after a couple of issues, we are back.
It's going to...
So to summarize where we are, now we are is about to define the guest input. So we define the guest input, and we are about to add the handler for doing this data binding, and some of the constraints around this input.
Receive event as its only parameter. And the first thing I'm going to do is say event.prevent default. And the reason for this, currently, or at least I guess previously, when I entered a guess and pressed enter, it was submitting the form using the default form behavior. And in HTML and the DOM generally, when you submit a form, it...
Oh my god, for real?
tries to make a new server request to the URL specified in action, right? So if I have like login.php, something like this, it's going to submit a request to this URL, taking the user there and sending the form data along for the ride. None of this is what we want. This makes sense in some contexts, but in React, we want to manage all of this inside JavaScript. So we're opting out of that default behavior, and what I'm going to do is log the guess value. And if you're wondering about these squiggly brackets, it's just like a little trick that I like. I could just log guess like this, but then it's just going to be a string that can get lost in a sea of other strings. By wrapping it in the squiggly brackets, as I type my guess, it logs as an object, which means that we get to see a little prefix as a way to distinguish this bit of logged information from other bits of logged information. It is a little bit annoying in that if the DevTools are closed when I submit my guess, you have to do a bit of work to unpack those values, right? It doesn't display the same way, at least not in the Chrome DevTools. But even with this caveat, I'm just such a fan of doing it this way. And I feel a little bit like I've wandered on a tangent, but the good thing is that when I enter my guess and press enter, the fact that we see it here means that things are working as we intend. So that's great. There is something about this that feels wrong to me though, which is in Wordle the game, everything is uppercase. There's no lowercase words, right? That doesn't really make sense. There's only a single case and it's uppercase. So we're going to tackle that. And I think the best place to do it is as soon as possible, right? The moment the input changes, let's make that modification here. And the way that I'm going to do that is I'm going to slap a toUpperCase method onto the value as we're getting it. When I do that, as I type, even though I don't have caps lock on, I'm not holding shift, right? It shows up uppercase. So pretty cool. There is a small thing though, and this is very subjective and very debatable. This feels like a lot to be doing on a single line, right? This is a pretty busy statement to me at this point. So I'm going to take this value and I'm going to pull it into a variable called next guess. As I say though, this is very subjective, right? If you prefer to do it all in one line, that's totally fine. Whatever is most readable to you. The next thing I want to do, so when I enter my guess and press enter, I want to clear the input out so that I can enter multiple guesses without having to like literally erase each of my guesses. It should erase it for me. And granted, we want to do something with that guess before we erase it, right? Like we want to make sure that we're saving it somewhere, but that is a task for a different exercise. So in this exercise, I'm going to call setGuess with an empty string so that it gets erased right after we log it. I go to the browser and I say hello, and I press enter. The value is shown here, and then it is erased. So things are working as intended.
Erase. Exactly.
I think the last thing we have left to do is the validation, right? Because I shouldn't be able to submit a really short word or a really long word. Every word in Wordle is 5 letters long, and so we should be enforcing that with constraints.
Exactly.
And the HTML that we got, right, the final value, doesn't include any validation because I wanted to make sure that was like part of the challenge here. I think a lot of JavaScript developers instinctively try to do everything in JavaScript. And so that might look like something like this, where when you submit the event, we add an if statement. We say if guess.length is not equal to 5,
Exactly,
then maybe we'll
because
do
most
a
of these validations
window.alert
are
and say
be done
please enter
by
exactly
by
5
JavaScript, but
characters.
you can do that kind of validation.
And I find window alerts can often feel a bit
in
aggressive.
HTML.
So I'm going to add a pink sparkly heart, just so that the user knows that we're not mad about it. Then I'm going to return because we don't want to do the rest of this stuff, right? If the validation fails, we want to bail as early as possible. When I do this and I enter a short guess, we do indeed see my alert. If I enter a really long guess, we see it. And if I enter exactly 5 characters, it submits the way we expect. And this is a fine way to do it, but it's more work than we need to do, or at least it's not necessarily the easiest path towards our final destination. What we can do instead is we can add HTML validations. So I'm going to add the word required, just to make sure that the form can't be submitted if it's empty. I'm going to say min length equals 5, and I'm going to say max length equals 5. When I do this, and I enter 3 characters and press enter, you'll notice I get this really nice and helpful error message that tells me to lengthen the text. If I try to enter more than 5, well, I actually can't. The max length attribute stops me from adding more than the 5 characters. To be clear, this isn't a React thing. I mean, the only thing that's React about this is that we're capitalizing the L, right? With JSX, you always want to have camel case attributes. But min length, max length, and required are all just part of the DOM. They're part of the HTML specification. And this again, right? React doesn't come with its own validation library because it defers to the platform. It wants us to use the built-in way of doing things. In theory, these 3 are enough, so we should be able to delete the stuff that we added up here. But I'm actually going to keep it because as I was preparing for this video, I noticed there were occasional times where I'd enter 3 characters and I would be able to submit it even though it failed the validation. Frustratingly, I haven't actually been able to reproduce this while filming because that's just the way that it goes. But I have seen other people complain about the same thing. So just to be safe, right? A little redundancy never hurt anybody. I'm going to leave this logic here, and we'll just keep our fingers crossed that it never actually gets this far because the built-in validation should have our back. So we've taken what was initially a pretty unsophisticated HTML form, we've added the validations, we've added the transformations, and we've made sure that React knows about what's happening. This seems like a pretty good accomplishment. I'm happy with that. So that's where this exercise is going to end. But in the next exercise, we're going to start actually using the user's submitted guesses.
Okay. All right. We're actually using is the min length and the pattern for that. Something that I explained that before. We're using is now pattern is to enforce is the type of input that we want to have here and the validations when that pattern is not fulfilled, right? So missing help circle here, and there you go. So in this video about help circles appear in the top right corner of the page. You might be wondering why your project doesn't include this icon. When I record this video, I had creating a help component that provide context about what this game was, but the code for it wound up being non-trivial, and I worry about distracting you from the task at hand. Oh, really?
So the starter code for this project...
Ah, exactly. So distracted from the task at hand. Okay. Right. So sorry for the confusion. Exercise 2, keep track of guess, right? You might wishing to revisit the iteration lessons to do so, which is indeed something that we explore that, and I render that as expected. But let's see what are the things that I'm missing here.
So when we type our guess and hit enter, that guess is blown into the wind, right? Thrown away like overcooked Brussels sprouts. And that's not ideal because in the real Wordle game, when you type your guess and press enter, wow, I thought for a second I was going to get it on my first try. That guess is shown to the user, and the second guess is also shown to the user, right? We see the results of our labor. It's not just thrown into the garbage. And that's what this exercise is all about. We want to take the guesses that the user enters and show them above this guess input. Now, this is a deceptively tricky exercise, and I realize that many of you will have struggled on this one, because while it might seem simple at first glance, it's actually pretty tricky to figure out how to manage the state for this kind of thing and how to use the state that we already have. But I'm getting a little bit ahead of myself. Let's talk first about the markup that we want, and I've taken the liberty of copying this from the README, right? So we have this markup right over here. Of course, I don't want to put it right here in the game component. It would be a little bit nicer to create a new component for it. So once again, I'm going to use the npm run new component command, and I'm going to call it guess results. And in guess results, I'm going to start by just hard coding this thing and changing class to class name. And in game, I'm going to import that component, guess results. By the way, if you're wondering how I did this little trick that I just did, it's a combination of two of my favorite keyboard shortcuts. So first, I duplicated this line. On macOS, the shortcut is Option-Shift-Down, and it will add one new copy every time you press the down arrow holding those modifier keys. Next, what I did was I double-clicked this and pressed Command-D, and I think this is Control-D on Windows, which will essentially duplicate the cursor, and you can do it as many times as you want. Then once you have the cursors in the right place, every instruction that you type will be added to both places. And so essentially what I did is I duplicated the line, and then I duplicated the cursor, and then changed the word input to guess results. It's a small thing, but I really love these little shortcuts that allow you to save microseconds here and there. But okay, so now I'm going to render this component, and what I expect to see is, yes, the hard-coded first guess. It's not really ideal because I don't want to see any guess, or I don't want to see these two hard-coded strings. I want to see the stuff I'm actually entering, but we're off to a good start. Unfortunately, this is where we kind of hit the bump in the road, because the state that I have right now inside guess input...
Hit the bump in the road. Hit the bump in the road. Bump in the road, man. Hit the bump in the road when it means to encounter a problem or difficulty that slows progress, often temporarily. Bump in the road. Bump in the road. Oh, so that's called bump? To slow you down. Oh, speed bump ahead. Oh, that's what they call. This is when we hit a speed bump. This is when they hit the bump in the road. Okay. Holy hell. I get it, bro. I get it, fella. Oh, crap. Bump, bro. In Argentina, this is called as... I don't remember that. But in Venezuela, it is called policía acostado, and which means is that it's a lay down police, right? I think that something might tell you what is this all about. I think in Argentina they call that is burro enlomado, something like that. I don't know. But again, it's this. This is when we hit the bump in the road. Okay, I'm learning is vocabulary here. Vocabulary. Oh my god.
Okay. It's inside guess input, which means I can't access it in guess results. And the standard solution to this problem is to lift the state up. Unfortunately, that doesn't really work here. And if you went down this road, you've probably kind of realized that there's something amiss here. And I think it's worthwhile to look at. So I'm going to go through that process, even though it doesn't really work. So for lift...
Oh, come on. Come on.
Lifting state up, what you do is you take the state hook and you essentially add it back as props. So guess and set. Guess will now be props. In the parent component, game, it's now going to be the home for this state. And I'm going to add guess is equal to guess, and set guess equal to set guess. If I do those two things and remember to save, it should still work the same way. And indeed, I see my guess and it gets erased. But now I have the state in the higher component, so I can pass it down to guess results. And this is where it may start to occur to you that I don't think this is quite right, because guess isn't really what I want to show. And it's made even more confusing by the fact that this is kind of what you want to show in the real Wordle game, but our game works a little bit differently. In our game, and hopefully you saw the recording of this earlier, we only want to show the guess once it's submitted. And so if I pass that prop through, and let's just say that I render it here for now, what you'll notice is as I type hello, it's an exact duplication, right? So whatever text exists over here will also exist over here. But that's not really what I want. What I want is for when I type hello and the moment I press enter, I want to transfer it so that it leaves this area and shows up in this area. That's the goal. And because of that, this isn't really the right approach. What I want to do instead, and let me briefly undo what we've done with lifting state up, what I want to do instead is I want to track a different bit of state up here. And essentially, I want to juggle the data between these two bits of state. And I'll show you what I mean. Let's create a new bit of state. I'm going to call it guesses, plural, set guesses, equals react.use state, and it's going to start life as an empty array. Then I'm going to add a new handler called handle submit guess. And I'm actually going to, rather than do it inline, I'm going to write a new little function up here, which is going to take guess as an argument. And for now, I'm just going to add a to-do. It's going to update this array to include this guess in that array. Then inside guess input, it's going to receive this handler as an argument. And instead of just logging the value out before we erase it, I'm going to pass that value up. Inside game, I guess first let's just check that it works. So I'm going to console.log received guess, and I type hello and press enter, and I do see received guess hello. So this is good. It means that we're on the right track. If we were working in a plain JavaScript context outside of React, I could do something like guesses.push guess, right, as a way to add this new guess that I've submitted into this array. But that's not really how it works in React. In React, you have to call the setGuesses method, and you're not really allowed to modify arrays or objects, so we have to kind of do this funky little dance where I'm going to spread the current guesses, and I'm going to add the new guess at the end. If the syntax is a little puzzling to you, right below this video, I'll link to the lesson in the JavaScript primer that explains the rest spread syntax. Essentially, it's the same thing as before, right? I'm creating an array that includes all the current guesses, and if there's none, then this has no effect. It's the same thing as doing .push, but in a way that creates a brand new array instead of modifying an existing array. Next, what I'm going to do is I'm going to pass the guesses to guess results, so the guess results will now receive this array of guesses. And eventually, we're going to do the proper thing, but for now, just to see that it works, I'm just going to log it out as one big string. So let's see if I type hello and enter. Haha, we see that it gets kind of passed around. If I say world, we see that gets added as well, right? It is now doing what we expect, which is wonderful news. I do want to address a couple of things. The first is that you may be thinking, well, isn't this a bad pattern? Isn't this an anti-pattern? Because maybe you've heard that state should have a single source of truth, and it's not good to copy between state like this. Well, that refers to something a little bit different. That refers to when you have the exact same information, the same bit of truth that is spread across multiple state variables. And that's not actually what we're doing here, because if you think about it, at any given time, right, the state in question is the word hello, and right now it exists exclusively inside guess input, inside that little guess state hook. The moment I press enter, I'm actually transferring it so that it is no longer being sourced in this bit of state. Now it's being sourced in this array, which is kind of in the parent level, so it encompasses both. So it's not so much that I'm duplicating the source of truth, it's that I'm transferring the source of truth. And I don't think there's anything wrong with that. In fact, I think that's the best way to do it in this kind of circumstance. Two more orders of business. The first one is
two more order
of
business.
Organization.
Two more order of business. Two more orders of business. order of business, a matter such as tasks that must be addressed. Okay, two more order of business. Order of business. Okay, this is very very specific to the Canada and the
thing,
custom.
just trying to keep things simple. It does bother me a little bit that I have guesses in game and I have guess inside guess input. They're so similar, and it kind of obfuscates the fact that they serve different purposes. So what I'm going to do is I'm going to change guess so that it's going to be called tentative guess, and I'm going to change set guess to be set tentative guess. The word tentative, if you're not familiar, it kind of means like preliminary, or maybe you can think of it as a guess in progress, right? It's something that may or may not become a final guess. And I like this distinction because it helps make clear that if you see the word guess in the code base, it refers to a locked-in guess. And if you see the word tentative guess, you know it's a different bit of state that's managed somewhere else. They're not the same thing. And I'm going to do the same thing up over here. In the handle submit guess, I'm going to change this guess to tentative guess. Right? None of this matters in terms of functionality. It works exactly the same way.
It's
It's just about mental models. I'm trying to make sure that when we
reliability.
come back to this code base, we're not tripped up by the fact that the word guess is so
Exactly.
ambiguous.
So we're not tripped
Okay,
up.
we have a single more order of business. We are almost done this exercise. The last thing to deal with is the actual rendering of the guesses, because I don't really want to be just turning them into a string, right? That doesn't really feel right. What I want to do is render one of these paragraphs for every item in this array. And whenever I have that situation, the solution that jumps out to me is to use .map on the array. So we're going to go through each of the guesses in the array, and for each of them I'm going to drop in one of these paragraphs, and it will receive the current guess as a string inside that paragraph. So when I do this, I can say, hello, world. Does seem to be working, although of course I have a very angry looking warning in the console because I've neglected to apply a unique key prop to each one. So let's fix that. How though? What should the key be? You might be tempted to use guess, but that doesn't really work because there's nothing stopping the user from entering the exact same guess twice, and then React really doesn't
No, I'm
like
using
that.
is now crypto.
What about the index? Should we use the
web
index
API
for this?
for that?
Well, let's try it. When we test it out, let's see, hello world. Yeah, we don't have any warnings. It is always worth thinking about implications. So the reason that we sometimes don't want to use the index for key is that React wants to uniquely identify each bit of data in the array, so that if the order changes, right, if I swap the order of these two, or if I delete one of them,
if I remove
which
the
effectively
dimension
means
of
that
the
this second
array,
thing becomes the
or
first
if
thing,
I
it takes its
swap
spot,
them in different order,
we can run into some funky
now
bugs
you can
if that is
run
possible
into some
and we're using
funky
index
stuff, right?
as the key. But when we think about Wordle, the game, guesses are locked in, right? There's no way to delete or change them other than like maybe if you want to restart the game, which isn't possible in Wordle, but you might imagine could exist. But in that case, we'd be blowing away everything, so we don't have to worry about that. So actually, in this situation, I don't think there's anything wrong with using the index as the key, and that's what I'm going to do. That does mark the end of this exercise. So if you're satisfied, you can move on to the next one.
In my
But
case,
just for fun, right? Just for education's sake, I want to explore how I would solve it if I couldn't use the index as the key. Maybe our version of the game does allow the guesses to be rearranged or deleted. What would I do then? Well, what I would have to do is I would have to track some unique identifier along with each guess. So at the moment that I create the finished guess from the tentative guess, essentially I'd have to stop treating it as a string. So what I would say is next guess is now going to be an object. It's going to have value, which is the raw string that we're currently holding, and it's also going to have ID. I'm going to use math.random. Right, this is a pretty good way to do it. There is a technical chance that you could develop the same random number twice, but it gives you like 15 digits, so the odds of it are negligible. If I really wanted to be overkill in terms of security or just making sure that it works 100% of the time rather than 99.999999% of the time,
so the percentage
I would do something like
give
this.
you a repeated value
the
is
guess,
astronomical.
so that the calculation essentially, in order to have duplicate keys, they would have to make the same guess twice and get the same number each time, which, the odds just went from astronomical to doubly astronomical. So then this would then be pushed into the array. So now every item in the array is going to be an object rather than a string, which means in my guess results, guess is now an object, and I could deconstruct that into value and ID, which would mean I'd use the ID for the key and the value over here. And so now, if I say hello, world, yes, it works the way you expect. And using the React Dev tools, I can actually take a little peek at this. Let's see if I can, so we see that the keys for these, and of course it's abbreviating it because it doesn't want to show you this many digits, but we see that each one does have this unique key, and if I include a duplicate guess, well, the word hello is the same, but this random number surely is not. So like I say, right, this is, I honestly would just stick with indexes, especially with some of the work that's coming. It's good to keep our code as simple as we can, and having guesses as objects just adds one more step in terms of complexity. So I'm going to undo all these changes. This is just for theoretical fun, and you can now continue on with the next video.
So in my case, particularly, is that two things here. So he used now to improve the readability of the state, which I do find that that's very accurate. And the other is by updating the state and providing now an ID. This is on the client side generation. So he is using is the math random. I use is a crypto web API random UUID methods that is provided by the web platform to go with that. Again, might be overkill, but for this case, I just want to use that for educational purpose. So we see some modern JavaScript trick in this one, including spread syntax, array destructuring, and object destruction, right? Exercise 3 guess slot. This is when it comes handy to create now layouts here.
So our game is starting to take shape. We have each of the guesses being rendered individually. That is good. But obviously, the presentation of these guesses still leaves a lot to be desired. When we compare it to true Wordle, we see that we have this very nice grid composed of individual cells, both for the letters that the person has guessed, but also for the slots that are remaining. So, in this exercise, we're going to transform this boring list of individual guesses into something that looks a little bit more proper. And inside our guess results component, we have these paragraphs being output. And at the time, in the last exercise, when we were just concerned with putting the strings out into the universe, I think this is a reasonable approach. You know, it is one of the constant challenges, the thing that you are constantly building your intuition for as a React developer, which is, when do I produce a new component? How much should I do inside guess results before I eventually say too much and decide to create, say, a guess component? And you can really do this at any time. There's no right or wrong answer. If you created a guess component in the last exercise, that's totally fine. But I know we're going to have to do some pretty complex stuff. Like from the README, I have this structure that we're going to have to generate, and that just seems like too much complexity for this component. So, once again, the now familiar process of typing npm run new component, and I'm going to call it guess. This name may be a little ambiguous, but given that we have gone through the trouble of distinguishing tentative guesses from true guesses, I think we have now established that guess refers to a locked-in guess. And at first, I'm just going to paste in the chunk of markup that we've been given, updating the class to be class name.
Come on.
And let's think about what the
I need high quality, bro. Oh my god. I need high quality, man, to provide my services.
API for this component should be. Well, I guess all we really need is the guess itself. And it always is a little, I don't necessarily like when the component name matches the prop name. We could use children, but because we're going to have to modify, we're going to have to kind of break it apart. that to me also feels like a bit of a code smell. So I'm just going to call it value, right? The value of the guess
Code
is the
smell.
actual word that the person has guessed. So inside guess results, let's import the guess component from // guess. And I'm going to put guess over here. The key needs to always stay right inside the map, right? It's on the React element that you're mapping over. So it's not that we have to come and put the key over here. I think that's a common misconception. The key needs to stay on the React element, not on the ultimate DOM node being created. And we'll set value equal to guess. Inside our guess component now. Just for the moment where we're getting everything set up, I want to kind of make sure that I haven't broken anything. And I see that this does appear to be working. Okay, so how do I do this? How do I get a span class name cell for each of the letters in this value string? Well, we can use the split method for that. And split often works with a delimiter, like maybe you have dash or slash, or maybe you want to separate on the dots or whatever. But in this case, I just want every character as its own element in the array, so an empty string will accomplish that. And then I'm going to map through these individual letters. So we'll say letter, and we'll take one of these spans and drop it in, making sure letter is the actual child. And hey, look at that. It now all of a sudden looks much more like Wordle should. But we're going to have, and I'll skip actually showing you this, the console's going to have an error because we've neglected a key again. And again, we have to think, is it a problem to use the index? Well, in true Wordle form, right, I'm never really rearranging the individual letters in a word, so I think it's okay. We'll set key equal to index. And when we head back, this is looking pretty good. Pretty good. Yeah, so what's next? Well, there is a problem, which is I always, in Wordle, want to be showing the 6 slots that represent every guess so that you know how many guesses you have left. Whereas in our game right now, we're only showing the guesses that you've entered. And this is actually kind of a tricky thing. We do have a bit of help. And let me actually get rid of this comment. Inside constants, we have this num of guesses allowed.
So what I'm going to do here is...
Which essentially means...
so in my case, what I did is just to, now that I'm going to render is the guesses, down below, I'm going to render the empty left guess allowed. Right.
Inside guess results, I always want to be rendering 6 guesses, regardless of whether the user has actually entered 6 guesses or not. So I'm going to import num of guesses allowed from our constants file. Then I'm also going to import this range utility from our utilities file. And we've talked about range in the first module of the course. As a quick refresher, if I was to call range 5, I would get an array with 0, 1, 2, 3, and 4, right? 5 items starting at 0, so we wind up with 1 less than the number we provide. And that will help us because I'll be able to always render 6 guesses instead of having it based on the number of guesses the person has actually guessed. So I'm going to replace guesses with range, and really I want it to be 6, but instead of using that hard-coded value, I will paste in this constant. Of course, what that means now is that guess, right, the first argument in this would actually be the number, the current number from 0 to 5 in this case, right? 6 numbers, 0 through 5. So I'm going to set the key to be this number. And even though this number is functionally equivalent to an index, as we've already established, it's okay to use the index in this circumstance, so it's okay to use this number as well.
And it is okay
but then,
because we're
how do I get the
modifying
actual
array
guess? What do I do here? Well, I can just say guesses num, right? Use the square brackets to look up if this is 0 for the first one, then get the first item in the array and pass that as the value. So when I do that, and when I save this file, well, we have a bit of a problem. We have an error, cannot read properties of undefined, reading split inside the guess component. So if we see what's happening here, right, value, this used to always be a string, because if I had 2 guesses, then I would render 2 copies of this component, and each of them would be given that guess. But now I'm rendering 6 guesses, which means that guesses 4 or guesses 5 is going to be undefined, right? I'm accessing a number that doesn't exist on this array, and then I'm running into a problem because I'm trying to call .split on what is an undefined value. And actually, we have a similar problem here, which is I might not have a guess, but I always want to render 5 individual squares for each slot. So I'm actually going to repeat the trick. I'm going to import the range utility from our utils folder. And then instead of doing this right here, I'm going to say range 5. Now, you might be wondering, why don't I have a constant for this, right? Why isn't there a constant like num of letters per word? And I could do that. Honestly, though, it would make it seem like it's an easy thing to change when it's not. With num of guesses allowed, I can just set this to be whatever number I want, and it would be totally fine. But with the actual words themselves, right, I have this data file with all of these 5-letter words. So it's more of a locked-in assumption that, well, we really need there to be 5-letter words for this game to work. And so because of that, it doesn't feel quite as important to me that we have it as a constant. It's going to be a pain to change this number if we need to change it, regardless of whether we have a constant for it or not. But okay, so I'm iterating through this. That means that the actual value that I have is number. We can use that as the key. But then what do I put over here, right? What is the actual content of this cell? Well, I could say value num, but that's not going to work if value is undefined. So what I'm going to say is if I have a value, then look up value num. Otherwise, we'll just drop an undefined in there. And when we look at our result, I am pretty happy about it, where I have...
So this is because this is how he create that logic here. Okay. In my case, I just say, hey, first, let's go to render is all of the collections from the word, okay? And then the empty slot. So my components is now computing is all of that guesses there. Right? So that's what my component is doing there, right? Is to render is the which is the guess. I call that guess. I call that guess result. But in any case, but in my case, what I render is that, right? That particular snippet of code to say, hey, let's go to render is first all of the guess words. And then the was left, the number of empty rows to render. And because this is something that's going to be computed over and over and over and over when one component changed, that's what I define that as it is, and not the way he describing is here as expected, as you can see here right now, right? As a guess result, which is render is now the guess, and so on and so forth. I do think that his approach is a little bit more verbose. It involves much more components, and aka, so what I can do is to I didn't want to actually create is a guess as it is, where guess is going to now render all of these characters, okay? I just in the guess result I just render is the inside of that, all right? I am doing this twice operations. It might be not or yes, depend of the readability, all right? I will argue that in the case of readability, it's way much more is accurate this way. So you define is now, hey, this box will contain is, so this box, all right, will contain is my guess results, and then this small box will contain is my guess to do so. So again, this is actually to, based on this component-based architecture, illustrate how all of these components are.
Utility from our utils folder. And then instead of doing this right here, I'm going to say range those slots. I do suspect that we're going to run into a little bit of complexity here once we start actually doing the game logic, but I am not going to get ahead of myself. That is something we will tackle in the next exercise.
So if we look now at the exercise 4, which is something that I take some time to actually figuring out how to create is the game logic. And in my case, it's to say, hey, well, the TLDR was, if I want to, I'm gonna make a naive approach to take this, both of these words that have this locally have the same length, right? And I want to iterate twice, aka I'm going to iterate for the first word, which is the guess, in the first letter, and I'm going to compare that against the second element, against the second, or against the answer, right? Against the answer's character, to see now if you, for example, have is the if that word actually is on the same spot, or in the and if it's not, it is present in the answer. Okay. So in my case, I do that naive approach, which is going into the how do you put going into this, so iterate twice here, iterate twice in these elements here. So because now the elements that I'm iterating are twice, the big O notation here is not n square, it's actually a linear time, because no matter how many elements do we have, I'm going to do that kind of operations is n time. So okay, good. The game logic was actually quite interesting, and this is when we apply now the styling exercise.
Over the past few exercises, we've been building the scaffolding and the structure necessary so that we're almost at the point now where this is actually a playable game. It's taken us a while to get here, but we are on the cusp of building something that could conceivably be called fun. So in this exercise, we're going to add the background colors that will allow the player to have the feedback so that they can know with their guess if they're on the right track or not, because really all it is right now is like a nice formatter, which is cool, but not really what we need. And the first thing that we need to understand is, how do I know what background color to provide, right? If we look at end result, we see that the main difference is that the span that holds each letter has this new class like correct or incorrect or misplaced. Well, we don't really have to worry about the game logic ourselves, unless you want to, in which case I would encourage you to spend some time tackling it. It's kind of a fun little JavaScript problem.
Yeah,
but
actually,
you don't have to do that. We are giving you the check guess function.
Actually, it's a very interesting.
What we want to do inside guess is essentially figure out what the result is for their value, right? For the guess that they've provided for this particular row in the game. And the check guess function takes the guess as the first argument, which is called value here, but it takes the answer, right? The correct answer as the second argument. Can't forget to actually import the function before we try to use it. But yeah, how do we get the answer, right? Well, in React, the main way that we get data into a component is through props. So let's add a new prop called answer. And that means that we have to give this component, when it's being rendered, this bit of information. Well, the guess component is being rendered inside guess results, right? We kind of iterate over this array from 0 to 6 and generate 6 guesses. So we're going to add the answer prop over here. Of course, this component doesn't have access to that information either, right? The correct answer is randomly selected up here inside the game component. So once again, we have to add that as a prop over here. And then inside game, we have to see where guess results is rendered and set answer equal to answer. Now, I realize I went through that pretty quickly, right? Jumping between files. So I think it's helpful to see a visual hierarchy of the components in our application from the top down, right? So at the very top of our application, we have our app component, It'll render a header component and a game component. Game then renders guess results and guess input, and guess results renders a series of guesses. We have access to this bit of information up here inside game, and we have to pass it down over here. And the way that we do that is we kind of drill it down through the component layer so that we pass it to guess results passes it to guess, and then we have it where we need it. This concept is called prop drilling, as if you are kind of drilling down into the ground for oil. It's seen as kind of an annoying thing in React, right? Like, it is kind of strange that guess results takes this bit of data and funnels it through, but it doesn't actually need this data itself, right? Guess results doesn't use answer directly. It's just forwarding it along like a fire brigade or a bucket brigade, that thing where they pass the bucket from one person to another. That's kind of what this component is doing. Later in this course, we're going to see other techniques, mainly using context as a way to pass data through our applications without having to prop drill.
Exactly.
But in the meantime, there's honestly nothing wrong with this approach. It works just fine. So now that we've funneled this data through, inside guess, we can see what the result is. So let's start by just logging it out. And what I see immediately is that we're shown the right answer as music, and then we get 6 of these things logged out, right? We're getting 1 for each guess slot, and since I haven't made any guesses yet, each slot reports null. If I enter my guess like hello, well, now this is interesting, right? The first guess slot now has a guess in it, and so we can see that we're given an array of 5 objects, and it just so happens that the word hello and the word music share no letters, so the status for each one is incorrect. If I update this to be something like movie, well, then we'll see that the first guess stays as hello with all the letters incorrect. The second guess will have some letters that are correct because both words share the letter M and the letter I in exactly the same spot. So essentially what we want to do now is to use this result to change the class name on this span, right? Looking again at the end result, we want to take the status from this object and apply that particular string to the class. This is one of those nice symmetry things where the statuses are exactly the same as the CSS class used for the styling. So that saves us a little bit of additional data manipulation. But how do we do that, right? How would I actually, well, it's clear to me that I'm going to have to make this dynamic because I need to figure out what to put there in which circumstances. And when the user hasn't guessed yet, right? So in the empty guess slots, we kind of want to keep things as they are, where it's just cell and there's no other class afterwards. So we could do something in here, but once again, my spidey sense is tingling, and I feel like that's too much complexity to happen all in this same component. So I'm going to create a new component, and unlike the previous times, I'm going to do it in the same file. And this is kind of a controversial thing. Like, there's an ESLint rule that was very popular for a long time that warned against creating multiple React components in the same file. Fortunately, the currents, the community pendulum is swinging the other way. People are realizing that actually it can be kind of useful to pack multiple components in the same file. For myself, I don't see anything wrong with it so long as the additional components are only ever used within this component, so I'm not exporting this and using it elsewhere.
So as long
and
as
so long as the overall
this
file isn't too
model.
overwhelming. So all the components have to be pretty small and can't cumulatively become totally overwhelming. So in this case, I'm going to grab this span. I'm going to return that in this cell component. I don't need the key inside here. I'm going to need that on the element being rendered inside the map. And now we have to figure out what the props should be, right? What is the API for this component? And I think we should keep things simple and make it the exact same, essentially, as these objects. So it should have a letter prop and a status prop. So I'm going to say letter and status.
Here.
We're going to use the status in this class name, right? So that it becomes cell and then whatever the status is. And we're going to use letter as the children for this span. I do, of course, have to provide those props to this element. So let's say that letter is equal to, well, what should it be? We have this results array. Result is going to be an array of 5 objects for each letter. And we're iterating over an array from 0 to 4. So we're going to say result num dot letter. And we're going to do the exact same thing for status. When I do this, I get an error. It says cannot read properties of null reading 0. And the reason for this is that result can be null, right? As we've seen in the logs, if I haven't entered a guess yet, the default value of that is null.
So
and we can even,
if we're
really curious about where that comes from, we can see inside the check guess function, if I don't give it a guess, it returns null. So what I'm going to do is I'm going to first add a check where
if
if
I
I have a
have
result, then
a
I do
result.
all of this stuff. Otherwise, it'll evaluate to
return is
undefined.
order.
And when I do that, let's see how it works. Haha! Fruit is all green. This is wonderful. Now there is a subtle problem here, and it's one that's easy to miss. If I inspect a cell that doesn't yet have anything in it, you'll notice that there is this undefined being added over here. And that's happening because status is the value undefined, and when you interpolate a string like this, it literally will just print the word undefined. Which isn't really what we want, right? Like, it doesn't cause any problems in this case because I haven't defined this as a CSS class, but maybe in some places it could cause weird little issues. So what I'm going to do instead is I'm going to say, in fact, let's do it in a variable. I'm going to say that class name is equal to, and then I'm going to have a ternary, and I'm going to say if I have status, then it's going to be cell with status interpolated in. Otherwise, it's just going to be the string cell. And I'm going to take that class name and drop it in this slot. The only thing left to do is to get rid of this unnecessary console log, and I think we can mark this one as completed. And with that, we have completed 80% of the exercises in this project, which I think is pretty darn cool. There's only a single exercise left to do. Focus, there we are. Yes, one more. It's going to be an interesting one too, because it touches on some of the intricacies about really getting fluent in thinking in a React mindset rather than just writing the React code. So I hope you'll keep following me on this journey. Let's do it.
Go ahead, man. Go ahead. Several students have taken a different approach for this one. They have evaluated the guess before adding to the state like this. So you check the guess, and then you get this as it is. At this point in this course, we're still getting comfortable with the fundamentals, and either solution is 100% valid. You can absolutely solve in this way. Let's say one of my happy practices is to store the minimum amount of stuff in a state and to derive things whenever possible. Later in this course, we'll revisit this exact problem, and I share my rationale for why I prefer to store the raw guess in state. It is not something you need to worry about now. Oh, okay, yeah. It's most likely conventions. Importing instead of passing prof. In my solution, I pass answer prof through the application, so our guess component can tell whether the guess is correct or not. Some student has instead solved this problem by exporting the correct answer and importing in the guess.js, which is an acceptable approach. This is totally fine. Honestly, it keeps the code a lot simple. So why did it do this way? Well, here's the catch. It only works for immutable data. We aren't allowed to ever update or change and import. One of the stretch goals of this project is to implement a restart feature where the user can start again with the brand new word. In this case, answer changes over time, and so we can rely on import and export. Similarly, in real-world projects, we're often dealing with data pulled from a database and sent over the network. In these cases, we also can rely on import and export because the data isn't known as first. Let's say, for this example, either approach is acceptable, and you can always refactor later if you want to give a stretch goal a shot. Warning and losing. This is something that actually take me quite a bit of time because it's not about JavaScript, CSS. It's more about is the React way, the React logic here, which is the conditional rendering here. To keep track of the game status, I recommend creating a status variable that can hold 3 possible values. Exactly. And this is interesting because even if I didn't follow this, I find out that that particular approach was indeed very useful to what we want to achieve, which is only allow me to show this banner when it is successful or you lost, or if it's running or if it is pending in my case. Then we can conditionally render a banner based on this status. So no banner for running, a win banner for won, and a lose banner for lost. You might wish to review the lessons of conditional rendering with double ampersand as expected. That's exactly what we did here. So that's why yesterday I hit the brake, I pause my mind, I create now a pseudocode to actually see how the intrinsics are, and then is when I now get this. You say, oh, okay, makes a lot of sense, especially when you want to show things like this. Holy moly, bro.
So with the game so far, right? As I'm entering words, I do get the status about them. If I enter the correct word, I see that I've won with the happy green background color. But I'm not really, there isn't really an end state to this game, because I'm free to keep guessing. And similarly, if I exceed the number of guesses, I'm not told that I've lost the game. In fact, I can keep entering these phantom guesses that aren't shown anywhere. So clearly we need an end state for this game to be complete. This is the final exercise in our Wordle project, and while it might seem simple at the outset, there are quite a few little complexities and things for us to trip over. So I'm really excited to talk about this. We're going to get in some pretty interesting territory in this one, so I hope you'll watch this video all the way through. So I'm going to start by adding a new state variable. I'm going to call it game status. And essentially this variable is going to track what the current game state is, like whether we've won, lost, or whether neither of those things are true. And I'm going to default it to the string running. And essentially that's going to be our three options. It's either going to be running, or it's going to be won, or it's going to be lost. And running just means that we haven't won or lost yet. We're in the middle of playing the game. For now, I'm just going to log status over here. Later we'll talk about adding a nice little banner that shows the user more visually. But for now, that's how we're going to do it. And in terms of how do I know when they've won or lost, well, I think the most intuitive place to do it is in this handle submit guess, because every time they submit a guess, it kind of runs through this function, and we have the perfect spot to do some evaluations. So I think we can consider the game won if the answer they give us, the guess that they submit, is exactly equal to the correct answer. So I'm going to say if tentative guess is equal to answer, well, then we can set the game status to 1. I'm also, this is probably a little bit too redundant, but I'm going to make sure that this is capitalized. And I say that it's redundant because in guess input, we're already turning it into an uppercase value even before it gets set into state. But I can imagine a circumstance in which this bit of code gets changed, and it just seems like a nice little bit of redundancy to have. I'm less worried about the answer because, we have this set of hard-coded values, and it would be really weird for us to suddenly start adding lowercase values to it. But I guess let's test that and see if it works the way I expect. So if I say, hello, the status remains running, but if I enter the correct answer of thing, hey, it tells us that we've won. What about for the loss condition? Well, they lose if they get to the end of the 6 allowed guesses without having triggered this condition. So if they haven't got the right answer, and if the number of guesses, so guesses.length, is greater than or equal to the limit, and we have that in this constants file, num of guesses allowed. So I'm going to import that from our constants. If it's greater than that value, then we're going to set game status to lost. And there is a subtle bug here I want to dig into. So in this case, the correct answer is heart. So I'm going to enter anything except that. And at this point, I've entered 6 incorrect guesses, so the status should be lost, but it continues to be running. It's only when I enter the 7th guess that it flips to lost. Why is that, right? Why is it 1 too late? Well, we could solve this by subtracting 1 from the number of guesses allowed, but that's a band-aid approach, right? It's better to figure out what's the problem so that we can address it at its core. And the problem is that the guesses array is stale. It does not immediately get updated. When we run this function, when we call set guesses, we expect that the guesses array is immediately updated. So if, at this point in the code,
This
guesses
is
dot
why
length
one
would
of
be
the
equal to
reasons why
5, right? If that would be the
Comeau is
case,
the
we expect
newest
that
state
immediately afterwards it
to
gets
that.
bumped to 6, because indeed we're calling set guesses and we're
This is
passing
why
it an
you
array
create
with 6
that, and
items.
to me was
But
that
the
not
way
a good
setters
idea.
work in React is that they don't immediately take effect. They schedule the update for the next
schedule will
render.
be,
So the next time this
updated
component
for
is
the next
rendered,
render.
guesses
Right.
will be updated to
So
be
a
this
good
array.
way to,
But for all the
or
rest
a
of the code
good
that comes
approach
immediately
here
afterwards,
is-
we haven't actually changed the value of the guesses array. This is one of the most common stumbling blocks in React, and is something that I still occasionally trip up over. So please don't feel bad if you got stuck here.
So
the way
what
to
I
fix
did
it
is just to
is to
define
pluck
is
out
a
a variable.
new
So I'm going to say
state,
next guesses
right?
is
Where
equal to
you
this
are going
array.
to update now the state.
I'm
Compare
going to
that
set
with
that so that we indeed
Okay.
do update the React state. But in the meantime, I'm going to use this next guesses array as the thing that I consider, because guesses is a stale value at this point, but next guesses is a brand new array I've created right here. Okay, so if I check and see that this works, I can enter 5 and then 6, and haha, it does update to lost. One thing that we should do too is when I've either won or lost the game, I shouldn't be able to keep entering guesses, right? This whole input should be disabled. So in guess input, I'm going to add the disabled attribute, and it's going to be disabled if game status is not, the next time this component is rendered, guesses will be updated to be this array. But for all the rest of the code that comes immediately afterwards, we haven't actually changed the value of the guesses array. This is one of the most common stumbling blocks in React, and is something that I still occasionally trip up over. So please don't feel bad if you got stuck here. The way to fix it is to pluck out a variable. So I'm going to say next guesses is equal to this array. I'm going to set that so that we indeed do update the React state. But in the meantime, I'm going to use this next guesses array as the thing that I consider, because guesses is a stale value at this point, but next guesses is a brand new array I've created right here. Okay, so if I check and see that this works, I can enter 5 and then 6, and haha, it does update to lost. One thing that we should do too is when I've either won or lost the game, I shouldn't be able to keep entering guesses, right? This whole info UI element that we can today. So the first way I'm going to tackle it is I'm going to create a new component called game over banner. And the idea is we're going to render this component in game, and it's going to manage everything that has to do with the game over banner concern, right? It's going to need to take game status as a prop. And essentially, if the user has won, then we're going to do the kind of happy condition where I'm going to grab the markup from the README and change class to class name. Otherwise, though, if they've lost the game, if game status is equal to lost, then I'm going to return the other chunk of markup from the README. Inside game, I'm going to import this component, game over banner. And if the user has finished the game, so if game status is anything other than running, then I'm going to render the game over banner, and I'm going to pass game status as a prop. When we consider this in the browser, we do see that because game status is lost, we see the banner down here. And if I enter the correct word, hover, then we get the happy banner. But there are some problems. The first problem is that there is some specific data that has to do with the win condition and with the loss condition. And if we check inside game over banner, we see that we've kind of hard-coded 3 guesses, but that's not what it should be, right? The number of guesses should be based on how many guesses they have. And we also need to include the correct answer, because there's nothing more frustrating than losing a game and still not knowing what the answer was. So let's add some new props. We could add guesses, the entire array, and then do a guesses.length over here. But just as a general principle, it's nice to give components the minimum amount of information they need, just so that it keeps it simpler for us, right? We know that this component doesn't actually care what the guesses are or what order they're in or what the actual texts are, right? All we care is how many guesses they've made. So let's change this to num of guesses, and we'll just render that kind of verbatim over here. We also need to know what the correct answer is, and we'll render that down over here. I need to pass both of these bits of information to our game over banner. So num of guesses will be equal to guesses.length. and answer will be equal to answer. It helps if you get your capitalization right. Never too much experience to avoid making that mistake. So now if I enter the word smile, I see congratulations, got it in 1 guesses. And there's 2 problems with this. One is that there's no space between in and 1. And also 1 guesses isn't grammatically correct. So let's fix both of those things. This is one of those really frustrating things in React where there is a whole bunch of white space between these 2 bits of information, but when we compile the JSX into JavaScript, it assumes that all of this white space is just for formatting, so we have to be very explicit and add a single white space character like this. To fix the grammar issue, I could do something like this, or I could say num of guesses is equal to 1, then have the string guess, otherwise have the string guesses, right? That works. But I'd rather do it all in one. So actually, I'm just going to have a single condition, and it's either going to be one guess, or it's going to be a dynamic string with the num of guesses number being interpolated within like this. All right, so we see congratulations, got it in 1 guess. If I go and get the whole thing wrong, hopefully, yes, it tells me that the correct answer is venom. So this is a perfectly valid solution, and if your solution looks like this, please don't feel bad by what I'm about to say. The only problem with this solution is, in my mind at least, it doesn't really fit well with how React wants to be used, right? We always hear this thing about React being about reusable components, but we haven't really built anything reusable here. We've built a very specific component to be used in a very specific case that's really more of a template than a component.
Exactly.
And another thing that bothers me is we have these 3 bits of information, but if I've won the game, I don't need to know what the correct answer is. And if I've lost the game, I don't care how many guesses they've provided. So I have all this information that is only used in half of the cases. And as a result, this component feels way more complicated to me than it has to be. So I'm going to fix this by creating a whole new set of components. And I'm going to start by creating a new component, npm run new component called banner. And the idea with this, banner, is going to be our reusable UI element, right? A more primitive UI component that is really just there for any situation in which we need to show a banner at the bottom of the screen, right? Maybe it's a login confirmation or one of those cookie banners or anything else that we need a banner for. This component should be usable in that case. The props here are going to be status. This is either going to be happy or sad, which affects the color of the banner. And children, which is going to be the content of the banner. It's going to return a div with class name equal to status,
to make it
like
more dynamic,
happy or
here.
sad, and then the word banner. And it's going to include the children.
The children
now,
here.
This honestly might feel a bit silly to you, right? Like you already have this banner class. Why don't I just use that as the way to reuse the styles, right? Like why do I need to create a whole component for this? And one of my favorite things about React is how it changes the mechanism of abstraction. So instead of having a class that you use in a bunch of different places, you have a component that you use in a bunch of different places. And that component can bundle not just the styles, but also any sophisticated markup, right? Maybe I need to have a bunch of other stuff in here, like icons. And any logic, like I could even incorporate the auto-hiding logic if I wanted the banner to go away after a certain amount of time. Having components as the thing that you reuse gives you so much more flexibility. And so even though it doesn't feel critical in this case, it's still a pattern I want to take advantage of. All right, next up I need another new component, and I'm going to call it one banner. And the idea is this is going to be the component that is shown when the user wins, and it's going to compose the banner component we just created. So I'm going to import banner, and I'm going to render that banner. In terms of the status, it's going to be happy because, you know, we should be happy. We just won the game. And in terms of children, the stuff shown inside the banner, I'm going to go to my game over banner and grab everything that was formerly inside this div, right? Inside what was the de facto component we were using. Of course, I still need to know the number of guesses. So I'm going to make that a prop for the one banner. The final new component I need is lost banner. And I'm going to start by copying everything in one banner, pasting it into lost banner. Of course, I'm going to change the name, lost banner, because it is going to be kind of similar. It's going to import the banner. It's going to render a banner, although this status is going to be sad. But then, of course, it doesn't make sense to render the happy content. I'm going to grab the formerly sad content, bring that over to the lost banner, and paste it in.
And pasted it here.
Instead of requiring number of guesses, though, it requires
Only the
answer. With that done, I can go back over to my game component, and I don't need Game Over banner anymore. In fact, I should probably delete it.
That by passing its dynamic content to
Won
that,
banner and lost
it is
banner.
way much more reusable.
And then instead of rendering a single banner with all of these props that aren't always necessary, I'm going to change the condition so that if the status is 1, then I render the 1 banner. I'm going to pass the number of guesses because that information remains relevant. And if the game status is lost, then it receives the lost banner with the correct answer. So, this does look very similar, and actually, before I go on a whole monologue about it, I should check that it actually works. So if I start with the win condition, I do see congratulations, got it into guesses. If I enter a bunch of gibberish, after the 6th guess, I get the correct answer in my sad banner. So yeah, this may seem like it makes weird trade-offs or like it was maybe better the other way, but the reason I prefer this implementation, A, is that it keeps individual components simple, right? One banner only receives a little bit of information, and you can very quickly get to the bottom of what this component is and what it's doing. And B, it takes advantage of composition, the idea that I have this primitive reusable component that could be used anywhere in this application, and indeed maybe even in other applications. I could create my own component library if I wanted, but all of the game-specific stuff exists within a game-specific wrapper component. And this idea is so powerful.
Exactly.
It's something that we're going to
exactly. And this, man. So you have now this base component that you're going to pass now some styles or some data, okay? And then now is the children's that allow you to now is pass down is the data that the specific data to that. This is like high order functions here.
Explore much more later in the course. And this idea is so powerful. It's something I could create my own component library if I wanted, but all of the game specific stuff exists within a game specific wrapper component. And this idea is so powerful. It's something that we're going to explore much more later in the course. For now, though, my hope is that this got the gears in your mind turning. Maybe you're starting to see things in this new and different way. Either way, though, I hope you had fun with this project. It was such a joy to create, and I hope you enjoyed it as much as I did.
That'll be all for this video. Take care. Bye-bye.